Hello everyone. Today we will learn the concept of atom according to the quantum mechanical model. Okay. So actually we will learn this topic according to the syllabus of class 11. So what happens in the initial stage, student does not know much more mathematics, so that's why they skip this topic at the initial stage of class 11. Okay. But today what we will try to do, we will use some mathematical tools to understand this concept, and sometimes we will skip some concepts and we will try to understand some concept with little bit tricky way. Okay, so let's start. Okay, so at first we will learn what is function. Okay, so our first concept should be function. Okay, let me start with a simple equation. Let's say z equals to xy minus x minus y plus 1. So in this equation, the values of z depends upon the values of x and values of y. So that means this x and y is independent variable and z is a dependent variable. So if I want to write this equation in the functional form, so I will write it z equals to function of x comma y. So in this equation, so x and y are independent variables and they are present within the bracket. Okay, and we will tell this z equals to function of x and y. So that means the representation in the form of function tells me that how many independent variables we need to explain a dependent variable. Okay, let's take another example. Let's say y equals to b square plus c plus d. Okay, so that means the values of y depends on values of b, values of c and values of d. If I change the values of b, I will get a different value for y. I will change the values of c, I will get a different value for y. If I change the values of d, I will get a different value for y. So I will write this equation in the functional form like that. Y equals to function of b, c and d. Again, it says that how many independent variables we need to explain the values of y. Okay, let's take another example. Let's say I have an equation which says that f equals to y k square plus b t square, and let's say k is a constant and b is a constant. So that means in this equation y and t are variables. So that means in this equation y and t is variable. Okay, so that means if I want to write this equation in the functional form, I will write f is the function of y and t. Okay, f is the function of y and t. Okay, let's take a very known equation. Let's say s equals to ut plus half a t square. Okay, ut plus half a t square. So in this according to this equation, the values of s depends on the initial velocity and the time and acceleration. So if I want to write this equation according to the function, so s is the function of, so values of s depends on u, t and a. So it will be u function of u comma t comma a. Okay, so this is called function. Okay, now let's take another equation. Let's say v square equals to u square plus 2as. Okay, so this equation says that the values of v depends on the values of u, values of a and values of s. Okay, so I will write this equation in the functional form like that. V equals to function of u, a and s. Okay, I think concept of function is clear. Now we have to learn the type of equations. Okay, now in the type of equations, at first we have to learn two different kinds of equations. Okay, one is ordinary equation and another one is differential equation. Okay, so what is ordinary equation and what is differential equation? So in general, if I said x square equals to 4, so what will be the immediate solution of this equation? X equals to plus minus 2. Okay, now I am writing another equation. Let's say dy upon dx equals to x. So this is also an equation and this is also a equation. Okay, now if we look at this equation contains some calculus term. So that means there is some ddx or ddy. Okay, so that's why this kinds of equation is called differential equation. Differential equation. So that's why this type of equation is called differential equation. So if any equation contains some differential form like dy dx, okay, some calculus term, so this equation will called a differential equation. Now this is a simple equation. There is no dy dx or d square d2y by dx square like that. Okay, so that's why this is the ordinary equation. Okay, so this is the ordinary equation and this is a differential equation. Okay, so when I will solve a ordinary equation, what I will get? I will get the values of x. Okay, so if this equation has a y term, and if I solve the equation, I will got the values of y. Okay, so when I am solving a ordinary equation, I am getting the values of x. Now let's solve this equation. So this is a differential equation. Okay, so we will categorize the equation into two parts. One is ordinary equation, one is differential equation. Okay, so what is differential equation? If any equation contains some calculus terms like dy dx, okay, some derivative terms like or some calculus terms, okay, so then these equations will called differential equation. Now if any equation does not contain any kind of differential form, so this equation will called ordinary equation. So this is an example of differential equation, this is an example of an ordinary equation. Okay, now if I solve the ordinary equation, what I am getting? I am getting the values of x, and in this example the values of x is plus minus 2. Now let's solve this equation. Okay, if I solve this equation, so I can write dy equals to x into dx. Now differentiate both sides. So what is the differentiation of integration? If I do integration on the both sides, so what is the integration of dy? So the formula says integration of dx equals to x. Okay, so this is the formula. So integration of y should be equals to y. Now we all know the formula of integration. It says integration x to the power n dx equals to x to the power n plus 1 divided by n plus 1. Okay, so this is the differential equation. Okay, now here the power of x is 1. Okay, so that means it's x to the power 1. So x to the power n plus 1, so that means 1 plus 1 plus 1, so that is equals to 2 divided by n plus 1, so values of n equals to 1. Okay, so this is 2. And for the simplicity, in this differential equation, I am not putting any constant. Okay, in general, according to mathematics, there should be a constant, as I am does not giving any limit. Okay, so this is the solution. So the final solution, y equals to x square upon 2. Okay, so this is the solution. Okay, let's write the constant, no problem. Okay, so this is the solution of this equation. Okay, so when I will solve a differential equation, what I am getting? I am getting a equation. I am getting a equation. Okay, I am getting an equation. So when I am solving a differential equation, I am getting an equation. When I am solving an ordinary equation, I am getting the values of x and y. Okay. Here in this case, in this equation, equation contains x term, so that's why I am getting the values of x. Okay. So the main difference in the solution of ordinary equation and differential equation is that in case of ordinary equation, by solving ordinary equation, I will get the values of x and y, or the values of dependent variables. But when I will solve a differential equation, that means a equation which contains some calculus term like dy dx, okay, so then I will get an equation. So if I solve an ordinary equation, I will get the values of x, y. But if I solve a differential equation, I will get an equation. Okay. Now look at the solution of this equation. In this solution, I am doing differentiation on y. Okay. Look at this equation. Okay. In this equation, the d dx term is present on y. Okay. So that means I am doing derivative on y, and the values are, and I am doing the derivative with respect to x. Okay. So in this equation, I am doing derivative on y. I am applying derivative on y. So that's why I am writing d dx, and I am doing the derivative with respect to x. Okay. So again, this equation, in this equation, I am doing the derivative on y, and I am doing the derivative with respect to x. So that's why I am applying d dx on y, and I am doing the derivative with respect to x. Now look at the solution. Here y equals to x square by 2 plus c. So that means the values of y depends on x. So I can write y equals to function of x. Y equals to function of x. Okay. So look at the equation, differential equation. Here I am doing the derivative on y. So my solution comes out y equals to, I am doing the derivative with respect to x. So that, and in the solution, y equals to function of x. So what I am observing, that on which parameter I am doing the derivative, my solution should be that equals to. So in this case, I am doing differentiation on y, my solution comes out y equals to. Okay. Now I am doing derivative with respect to x, so y equals to, my solution comes out y equals to function of x. Okay. So that means when I am doing the derivative, on which term I will do the derivative, this should be the dependent variable, and my solution come out will be that equals to. Okay. My solution will be that equals to, and here I am doing the derivative with respect to x. So that's why my solution comes out y equals to f of x. Okay. So that means, okay, let's take another example, then it will be little bit more clear. Okay. It will be more clear. Okay. So let's say dp upon dt equals to a constant k. So here a differential term, derivative dp and dt, differential term is present, so that means it's a differential equation. Differential equation. Okay. Now look at the equation. I am doing the derivative on p. I am in this equation, derivative is done on p and with respect to t. Okay. Now let's do the solution. Okay. dp equals to k into dt. Okay. So if I do integration on both sides, so dp equals to, so integration of dx equals to x, so integration of dp equals to p, equals to a constant into dt. So always in the integration, the constant come out from the integration sign and it will be dt. So p equals to, so integration of dt again t, so k into t. So this is my solution. So that means the values of p will depend on the values of t. So p equals to function of t, but not the function of k, as the k is a constant. Okay, I am taking k as a constant. If k is not a constant, then the derivative will be little bit complicated. Okay, k is a constant. K is a constant. Okay, so that means in this equation I am doing derivative on p, so that's why solution come out p equals to, and I am doing the derivative with respect to t, so that's why the solution comes out function of t. So p equals to function of t. So look at the pattern. When my equation is dy dx equals to x, my solution is y equals to function of x. So here I am doing the derivative on y, so solution come y equals to, I am doing derivative with respect to x, so equals to f of x, function of x. Here I am doing derivative with respect to t on p, I am doing derivative on p, so p, so in the solution equation p equals to, and I am doing the derivative with respect to t, so it comes out function of t. Okay, so in general, on which parameter we will do the derivative, my solution come out as this function equals to, and this equals to should be the function of that parameter by which we are doing, with respect to that parameter we are doing the derivative. Okay, so this is the general pattern. Okay, so this is called differential. So what important mathematical tools we learn? At first function, and then we will learn ordinary equation and differential equation. So by solving the ordinary equation, we will get the values of x and y, and by solving a differential equation, that means that the equation which contains some calculus part. Okay, by the equation that contains some calculus part. Okay, if I solve these kinds of differential equations, we will got an equation. And what is the pattern on the equation? On the equation on which we will do the derivative, in the solution it come out that parameter equals to, and that should be the function of that parameter by which we are doing the derivative. Okay, or with respect to which parameter we are doing the derivative. Okay, so this is the important mathematical concept we will need in this topic. Okay, now let's go to the main topic. Okay, so these all are the mathematical tools we need to understand the quantum mechanical model of atom. Okay, but remember a thing. Okay, which the things we are I am telling here is not the correct way of teaching this topic. Okay, this all things are not correct in the larger sense. Okay, so this is only but this is good for the class 11th level. Okay, so sometimes dx by, let's say dx by dt, sometimes there is written dx by dt, so it may be written in the other fashion like del x by del t, but there is a difference in, so this is also the notation of derivative, and this is also the notation of derivative. So this is the notation of calculus, and this is also the notation of calculus. Okay, so dx by dt means I am doing derivative on x with respect to t, and this del x by del t means the same, I am doing derivative with on x with respect to t. Okay, so d dx and del x del t is the same thing, but this is called partial derivative, and this is okay, so this is called a partial derivative. Okay, so that means we can tell that d dx in any equation, if we got the d dx term, this is also differential equation, but in any equation instead of d dx, if we find some del x, okay, or del y, or something like that, we will also tell that this is also a differential equation. Okay, so that means del dx dt and del x del t means same, both are the means both means differentiation. Okay, so now come to the main point, Schrodinger equation. Okay, so I am going to write the large equation that is written in your book. So the equation says h cut square by 2m del square psi by del x square. So that means I am doing derivative on psi with respect to x. I am doing derivative on psi with respect to x. Okay, I am doing derivative on psi with respect to x plus del square psi. I am again doing derivative on psi with respect to del y square. So at first, so h cut square by 2m minus h cut square by 2m into del square psi. So that means I am doing derivative on psi by del x square with respect to x plus I am doing again derivative del square psi with respect to y. So del y square plus I am doing again derivative del square psi by del. Now I will do the derivative with respect to z. So del square. Okay. So minus h cut square by 2m del square psi by del x square plus del square psi by del y square plus del square psi by del z square. So that means I am doing the derivative on psi with respect to x. I am doing the derivative on psi with respect to y. I am doing the derivative on psi with respect to z plus the potential energy plus psi equals to the total energy into E psi. Okay, so this is the equation. Okay, this is called Schrodinger equation. Okay, so in Newtonian mechanics, F equals to ma is the mother equation, and in quantum mechanics the Schrodinger equation is the mother equation. Okay, so now if we look to this equation very carefully, what we are observing, there is a differentiation del term, del square psi del x square. So that means some calculus term is present here. So that means this is a differential equation. The first, by looking this equation, what we can tell that this is a differential equation as it contains some differential term or calculus term like del square psi del x square or del square psi del y square, del square psi del z square. So as this equation contains some calculus term, so that means this is a differential equation. So in the previous examples we learned that when we will solve a differential equation, we will get a equation, and if we solve an ordinary equation, we will got the values of x and y. So that means we will got the values of dependent variables. Okay, so as this is a differential equation, by solving this equation we can tell that, by looking this equation we can tell that if we solve this equation we will got a equation. Okay, so first thing, by looking this equation, what we can tell that if I solve this equation I will get a equation. Okay, as this is a differential equation, by solving this equation I will get a equation. Now just recall the previous examples. When you are doing the derivative on y, so that means you are writing dy by dx. So that means when you are doing the derivative with respect to y, when you are doing the derivative on y with respect to x, in the solution you are finding that y equals to function of x. When you are doing the derivative on p with respect to t, in the solution you are getting p equals to function of t. Again I am repeating, when you are solving the equation dy upon dx, so that means when you are doing the derivative on y with respect to x, you are getting the solution y equals to function of x. When you are solving this equation, when you are doing derivative on p, so you are writing dp with respect and you are doing the derivative with respect to t, so you are writing dp upon dt. Your solution equation is p equals to function of t. So now look at this equation. You are doing derivative now at the looking on this equation, you can tell that you are doing the derivative on psi. Okay, so that means your solution should come out equals to psi equals to. Okay, so very simple. Sure. So looking on this equation, you can tell that that solution should be psi equals to. Now this equals to, now you are doing the derivative with respect to x. Okay, so that means that should be comes out that psi equals to function of x. Now again, I am not stop here, I am doing again the derivative on psi with respect to y. So that means psi will be the function of y, and I am doing derivative on psi again with z. Okay, so that means psi should be the function of z. Okay, I think it's clear. Okay, so I am repeating again what I am doing, what is my logic behind writing this. Okay, so my logic is that when I am doing the derivative, on y with respect to x, I am getting the solution y equals to function of x. When I am doing the derivative on p with respect to t, I am getting the solution p equals to function of t. So as in this equation, we are doing the derivative on psi, so that should be psi equals to, and I am doing the derivative with respect to x, so that's why it is a function of x, and also I am doing the derivative with respect to y, so it's also the function of y, and I am again doing the derivative with respect to z, so that means this is also the function of xy. So the solution of this equation, the solution of Schrodinger equation should be looks like that. Okay, the solution of Schrodinger equation should looks like that: psi equals to function of x, function of y, and function of z. Okay, so I think this is clear why I am writing these kinds of things. Okay, now